okay, let us write down the proof of algorithm in polynomials, theory of equations, division algorithm. Statement: let a of x and b of x belong to R of x. Polynomials over real. Let b of x not be zero polynomial. Then there exists unique q of x comma R of x belonging to real polynomials over real such that 1 a of x is equal to b of x into q of x R of x, and 2 either R of x is zero polynomial or degree of R of x is strictly less than degree of b of x. Okay, so before writing the complete proof theorem, this is theorem, we would understand what is the mechanism which is going on, and then writing the proof is going to be relatively simpler. So let us try to do numerical first. We want to divide. So a of x, let two x raised to 4 plus 5x cube minus 3x square plus 5x plus 6 and divisor polynomial be x square plus x plus 2. Okay. So if we really perform a long division of these, which we will do, and let us perform long division. 2x raised to 4 plus 5x cube minus 3x square plus 5x plus 6 is to be divided by x square plus x plus 2. So quotient. First we have to have 2x square. So 2x4 plus 2x cube plus 2x square, right? Which means 0, 3x cube minus 5x square plus 5 plus 6.
So ते 4x square असायला पाहिजे. 2x raised to 4 plus 2x raised to 3 plus 4x raised to 4. Sorry, 4x raised to 2.
Okay.
Sir, 4x square पाहिजे तिथे.
Yes, sir.
Sir, in the second step of the doing plus 4x square.
अच्छा इथे हाँ 4x square. Therefore it should be 7 here. बरोबर है? Good. Now So the next is going to be 3x. 3x cube plus 3x square plus 6x will minus 10x square minus x plus 6. So minus 10 is equal to minus 10x square minus 10x minus 20. Therefore 9x minus plus 26. Okay. So a of x is this, b of x is this. We happen to get q of x is equal to 2x square plus 3x minus 10, and our r of x happens to be 9x plus 26. It is not equal to 0, therefore degree is 1, degree of b of x is 2, so everything is falling in place. This is our long division. Okay, now we go back and try to establish some results over there. So here, using this, can we find out all possible remainders? Now this is our final q of x and final r of x. But can I say that q1 of x is equal to 2x square and r1 of x is equal to 3x cube minus 7x square plus 5x plus 6? Because if I multiply, is this going to be true? Is equal to q1 of x multiplied by b of x plus r1 of x. Is this going to be true? If I write q1 of x as 2x square, yes. R1 of x as this, yes. This statement is going to be true, right? Yet another q1 I can find out, q2 I can find out of x is equal to 2x square plus 3x. If I write q2 of x, then my r2 of x is equal to minus 10x square minus x plus 6. If I put these two values back into this equation, will I get my a of x back? Of course, yes. Now, in fact, there are infinitely many q1 of x, and therefore corresponding r1 of x will be again infinitely many. Now, suppose I would not have written these two here in the first place, or if I would have written half. Let me explain what I am trying to tell you. All need not be integers. All the coefficients need not be integers. Suppose 2x raised to 4 5x cube minus 3x square plus 5x plus 6 is divided by x square plus x plus 2, and I write quotient as maybe half x. Yeah, that is fine. So this is 2, if I write half x as my quotient, then what is my multiplication here? Half x cube plus half x square plus x. I have to subtract from them, and hence I will get 2x raised to 4. 5 अर्धा केलं 4.5 minus plus 9 by 2 plus 9 by 2. Oh. X cube minus 7 by 2x square plus 4x plus 6. Okay, Q3 is Q3 of x is equal to half x, and R3 of x is equal to 2x4 plus 9 by 2x cube minus 7 by 2x square plus 4x plus 6. And that is what I want to tell you, that there could be infinitely many q of x and infinitely many r of x. which eventually will solve, will solve Ax is equal to that equation. That equation will continue to remain true such that these two guys are, this number 1 is true in every q1, q2, q3, r1, r2, r3, etc. This first equation happens to be true. So there are actually infinitely many remainder polynomials by this, whatever multiplication and remainder that we are saying, there will be infinitely many remainder polynomials. But then which one to say that it is r of x is the one, either it is a zero polynomial or whose degree is less than that of b of x. And now you will observe that except this remainder polynomial, everybody had a degree greater than b of x. So the division algorithm is all about finding out that unique r of x, who is either a zero polynomial or a unique polynomial in that remainder box whose degree is less than b of x. Okay, so the idea is very clear about this proof. You collect all remainder polynomials and start comparing their degrees, and eventually you will find out one polynomial whose degree is less than b or equal to zero polynomial. That is what is going to be our remainder polynomial, and therefore these two statements are going to be true. So now follow me as far as the proof is concerned. Proof. I have 20 minutes and it is easy for me to write. Consider S, the set of all polynomials such that a of x minus b of x into p of x. Any other quotient polynomial whose name is given q of x, where p of x is r of x. This is the correct way of writing. Whatever numerically we have carried out here, this is the correct way of writing. And now what is this box? Box S contains all possible remainder polynomials which will satisfy this equation. Okay. Case 1. If zero polynomial belongs to S, then there exists q of x belong to r of x such that a of x minus b of x into q of x to 0 implies a of x is equal to b of x into q of x plus 0, which is desired result. Case 1 is easy. If you happen to have a zero polynomial, that means this is producing 0. That is what is written here. And in that case, we will call that p of x equal to q of x. Therefore, the requirements are satisfied. Case 1 is simple. Case 2. S does not contain r of x, zero polynomial. Case 2. Zero polynomial is zero polynomial does not belong to S. Therefore, there exists some r of x belonging to S such that for every r dash of x. If you pick up any other remainder polynomial from the same box, then degree of r of x is less than or equal to degree of r dash of x. Now this is important. I think this we have done in our number theory division algorithm also. In a box there are all possible remainder polynomials and zero polynomial is not available. Then there will exist one r of x such that its degree is minimum. That is well ordering principle. As far as all degrees are concerned, they are either 0, 1, 2, 3, 4 and so on. Therefore, by well ordering principle, there exists a minimum which is going to be amongst all available degrees, there will be a minimum degree, well ordering principle. And therefore, this statement is going to be true. Now, equality is allowed because we are proving existence of r of x in the box. Once we proved existence, we will write the proof for uniqueness, that it is not going to happen that r of x, r1 of x and r2 of x, there will exist two polynomials, remainder polynomials, whose degree is same, and it is minimum. I mean, if it is minimum, then it has to be unique. That is what eventually we will prove. So if we have written this statement right now so far, then what is our claim? What are we supposed to prove? Okay, we are supposed to prove claim degree of r of x is less than degree of b of x. That is what we are supposed to prove. So of course we have to use indirect method if possible. Let degree of r of x is greater than or equal to if degree of r of x is greater than or equal to degree of b of x. Now every time we have to keep writing this, therefore we will have to assign something. Okay, but then let me go as per the notes. We will show that there exists r dash of x belonging to S such that degree of r dash of x is less than degree of r of x, contradicting this statement. This statement is star. Okay, so we will have to show that if degree of r of x is greater than or equal to degree of b of x, then there will exist another polynomial r dash of x whose degree is going to be smaller than degree of r of x, contradicting this statement, because by well ordering principle we have said that there will exist r of x whose degree is going to be minimum. There will exist, I mean unique or not we are not saying, but it will exist r of x whose degree is going to be minimum. Okay, so degree of r of x, if we show r dash of x, if we show less than degree of r of x, we will contradict. Okay, so as r of x belongs to S, there exists Q of X such that R of X is equal to A of X minus Q of X into B of X. Let degree of B of X is equal to capital B and degree of R of X be equal to capital R. Let R of X is equal to R X raised to R plus R minus 1 X raised to R minus 1 plus dot 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 plus R0. Let B of X is equal to B X raised to B plus B minus 1 X raised to B minus 1 plus dot 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 plus B0. We started with R greater than or equal to B. As R is greater than or equal to B, that means degree of this polynomial is bigger than or equal to this. Perform long division. Which we will try to perform here. B X raised to B plus B minus 1 X raised to B minus 1 plus dot 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 plus B0 is our divisor. What is our dividend? R X raised to R plus R minus 1 X raised to R minus 1 plus dot 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 plus R0. It is easy. I mean, we are just going to perform one step and then we are done. Okay. So, what is first coefficient here in quotient? Can somebody tell me what is the first coefficient in quotient here? R upon B X raised to R minus B. Is that correct? Because we want this to be 0 after subtraction. So this is my first. And then there will be something. Okay. So, of course, here it will be R, capital R, X raised to R plus something. And then this is going to be 0 plus something. Is that correct? This is our long division. Why is it blinking? This is our long division. Are itka samajhte ka? This multiplied by this I have written here. And there will be many other terms which I am not writing. This will be 0. And definitely the remainder polynomial which is remaining here will have coefficient x raised to R minus 1. It is not R, but R minus 1. Degree of this remainder now is going to be R minus 1, capital R minus 1. So consider R dash which is equal to, consider R dash which is equal to R of X, that is this, minus what you have got here is RB upon BB, sorry, RR upon BB, R of X minus RR into X raised to R minus B upon b into b of x. So if we simplify this little bit, what we will get is, what is our r of x? Our r of x we have found out from the box. And the box says r of x is equal to a of x minus b of x into q of x minus rr upon bb x raised to r minus b into b of x, which again here b of x is common. So what we can do is we can take it common and put something inside the bracket. So a of x minus b of x, which is common inside bracket, q of x minus r upon b x raised to r minus b. Oh, but then this square bracket is yet another polynomial. This is equal to a of x minus b of x into some polynomial p of x. This is polynomial. So this r dash of x, r dash of x is this. Actually, r dash of x is this. R dash of x is something x raised to r minus 1 plus something dot dot dot. So what is the degree of r dash of x? Actually, it is r minus 1. So let us finish this. By definition, r dash of x. So this is p of x box, and hence this implies r dash of x belongs to S, because S was the S was the set of all those who follow this, and r dash also follows this. Therefore, r dash should have been in the box itself. Now, note that degree of r dash of x is equal to r minus 1, which is less than r, which is degree of r of x, contradiction. Contradiction to star implies whatever we have assumed, whatever, if possible. Where is if possible statement? That is what is our assumption. Where is if possible statement? If possible, degree of r of x be greater than or equal to degree of b of x is false. Contradiction to this implies degree of r of x is less than degree of b of x. So this is first part of the proof, existence. Now very quickly I will finish the uniqueness also, and you need not have to actually write down this also in detail because it is there in the lecture notes, but if you are keeping yourself busy by writing, and by writing if your understanding is better, it is always good to write. So now let me write down the uniqueness.
Sir,
Yes.
sir, I have a doubt. Consider r dash the left side मध्ये blue starting मध्ये ते consider r dash x as the third statement मध्ये ते in the bracket qx plus असायला पाहिजे ना, plus rr.
Yes, yes. Plus असेल. Correct. Okay. Now, uniqueness. If possible, let there exist r1 of x, q1 of x, and r2 of x, q2 of x belonging to r of x, satisfying division algorithm, that is a of x is equal to b of x into q1 of x plus r1 of x, which is equal to b of x into q2 of x plus r2 of x. Either r1 of x is equal to 0 or degree of r1 of x is less than degree of b of x, and similar for other. That is, r2 of x should be 0 or degree of r2 of x should be less than degree of b of x. Okay, so these two statements imply b of x is the same polynomial present in both the places here. Okay, therefore what we can do is b of x into q of x, q1 of x plus r1 of x is going to be equal to b of x into q2 of x plus r2 of x. Now taking same things on one side, b of x inside bracket q1 of x minus q2 of x is equal to r2 of x minus r1 of x. बराबर है? What are we trying to prove? We should prove that q1 of x is equal to q2 of x and r1 of x is equal to r2 of x. That is what is the uniqueness that we want to prove. Therefore, we started with otherwise that they are not equal and still they exist in the box. And now we have reached this stage. We have reached this stage. And we should search for contradiction now. So, can you help me in finding out a contradiction at this stage? And there exists a contradiction here. B of x into q1x minus q2x is equal to r2x minus r1x. Here we have already proved r is less than b. So if we compare the degrees, b of x has got degree capital B. Q of x will have some degree or it might be 0. So multiplication of the two polynomials is either addition of the degrees. Addition of the degrees. So this is degree of LHS is going to be degree of LHS is greater than or equal to B, and degree of RHS is strictly less than B. Contradiction implies q1x is equal to q2x, r1x is equal to r2x. Uniqueness proved. Division algorithm proved. My job is over. Go through it. If not understood anything, we have got a couple of minutes, or we can discuss this in the next lecture also. Right.